This is the Unit 6 test review. The first questions here, basically through 21, are all no calculator problems, so we'll start it like that. For these first two questions asking us to graph the function, by first graphing the parent function, you don't necessarily need to use a dash line, but just showing those points. And then it wants us to state the domain and range of the given function and make sure we clearly show specific points on both the parent and given functions. Label any horizontal asymptotes. When we first look at this, we need to decide, is it an exponential function or is it a log function? In this case, we're looking at an exponential function because it's 3 raised to the x. So our parent function is y equals 3 to the x. Here we just build an xy table of just some easy points. Honestly, since we're only using 2 points for log, I'm okay with 2 points for exponents too. The first point that I always like to plug in is 0 for x. That would give us out 1 for y. And then I like plugging in 1 for x. That gives us out 3 for y. So we go 0, 1. And then we go 1 up 3, which puts us here. Remember that in our parent function, that horizontal asymptote is always going to be at y equals 0. Now we need to do any kind of translations to this thing, or transformations, I mean. Here we can see that there's an a value, so we need to multiply all of the y's by the a, so multiply both of those by 2, which would put this at 2, and then this at positive 6. So then we're going to go 2 and positive 6. And then the last thing it tells us to do is to shift all of those points to the right one. So right here, we're going to go right 1, right 1. There is no vertical shift moving that horizontal asymptote up and down, so it stays at the same place, and then we can just go through those 2 points. The domain for our exponential function here is always going to be all real numbers, and then the range for this function is going to be parentheses 0 to positive infinity because it's going up forever. Okay, let's take a look at this next one. This next parent function has a base of 1/3 and it's being raised to the x. So then we have y is equal to 1/3 raised to the x. So we build our xy table here. Again, I always like 0 because that gives us 1, so we're at 0, 1. And then I like to plug in 1, that gives us 1/3. So 1 and 1/3 is about right there. We can draw in our horizontal asymptote at y equals 0. And then we just do any transformations. In this case, the transformations are telling us to go left 1 and up 2. So we take all of these points to the left 1 and then up 2. Left 1, up 2 puts us here. We can't forget also that the horizontal asymptote will move up 2 with that vertical shift as well. So we have a new horizontal asymptote at y equals positive 2. And then we just go through those 2 points. And there's our exponential decay function. Domain is always all real numbers. And in this case, the range is going from, we're at positive 2, and then it will go up into infinity. All right, this next one says tell whether the function represents exponential growth, exponential decay, or neither. Here we have 5/4. 5 is bigger than 4, which means this is a b value that is greater than 1, which would tell us that this is, in fact, growth. For number 5, right below it, this is a b value that again is greater than 1, so we also have growth. For number 4, this is a b value that is less than 1, but that b value is also bigger than 0. So this is decay because we're less than 1. And then this last function right here, this is actually not exponential. This is a cubic function, so it's neither. All right, next it's asking us to simplify the expression. In this first one, number 17, we have a base of 13 being raised to a log base 13. Our solving has shown us that these two things cancel. The only thing that gets left is just x. For 8 here, we're simplifying e's. When we multiply two of the same bases, we can combine them and add their exponents. So 4 plus 2, this would give us e to the 6th power. For number 9, there's a couple ways to do number 9. I like to, since these e's are both in the top, combine them. So we would get 6e negative 2 plus 2. That's over 3e. And so that then becomes 6e to the 0 over 3e. E to the 0 is just 1, so that's 6 times 1 over 3e. And then we can just reduce this 6 and 3 to get 2 over e. And then number 10 here, we're in a square root, so we can only take out perfect squares from inside of here. 81 is a perfect square, so that we square root 81, we get 9. E to the 9x, we can't take 9x and divide it by 2 evenly, so we need to get a number that we can divide by 2 evenly. So that would be the square root of e to the 8x and the square root of e to the x. E to the 8x square rooted would be e to the 4x, because what this is doing is it's taking e to the 8x and it's dividing that 8x by 2, which gives us 4x. So then we have 9 outside, we have e to the 4x outside, so this is 9e to the 4x, and then the square root of e to the x would be inside of a square root. All right, and that is the first page of the review.